So if we can start just by having a sort of overview of Johnson Controls, your sort of approach to fire protection. Obviously today you've been particular reference to data centers and server rooms. What's the company's sort of overall approach?
So Miguel, do you want to take that one?
Sure. So Johnson Controls has a comprehensive approach to the fire protection in data centers. So we offer a complete portfolio for detection and a complete portfolio for suppression in data centers, and we have a full range of different type of fire protection solutions. So inert gases, halocarbons, or even water-based solutions for the protection of generator rooms and such. So both for small, mid-size, and big data center, we have a complete range of solutions that would cope with the different type of risk in the different type of processes in the different rooms in a data center.
Okay, and in terms of the challenges, you say obviously you've got a portfolio to address, but what would you characterize or identify as the main challenges in terms of fire protection suppression issues within data centers? Yeah, as you say, whether it's from small, I guess, almost cupboards under stairs, all the way up to huge, great, mega data centers. What sort of things do people have to watch out for?
Yeah, in a data center, there are different type of processes running in the different type of rooms. So if we take the data hall, typically there's a huge amount of energy flowing through the infrastructure, and within those processes there can be a type of electronic fires, so type of smoking, smoldering fires that need to be detected very early in the development process, usually with aspiration type of technologies, and then trigger an intervention, so an alarming and a flooding with an extinguishing gas as early as possible to mitigate potential damage or potential sources of fire being transmitting from the original equipment in trouble to additional kind of infrastructure nearby.
Okay, and in terms of looking at specifics, I mean, am I right in thinking that sort of noise and the bigger sort of description of that acoustics, are those particular concerns within the data center server room environment? Yeah,
so if I go back to the different type of rooms, so in the different type of processes being run in the different type of rooms in a data center, I mean, a data center, it's a complex type of operation involving different type of processes. If we take the data hall, there'd be a lot of sensitive equipment, and those equipment are sensitive to noise and vibration, and we'll have Alan comment on our solutions for acoustic control fire suppression in a minute. But going back to the other rooms, you have different type of fire origins. So if you take a generation room, there can be a potential for open flame fires coming from generators, or coming from fluids, combustible fluids. So in those type of rooms, we want to have a different type of detection and actuation, so different type of suppression systems. In a battery room, which is becoming more and more popular in the data center environment, being able to store reliably big amounts of energy that would be readily available in case of utility power shutdowns. Those type of rooms present again a different type of risk related to the lithium-ion batteries, and in those type of rooms, again, we want to have a different type of detection technology and suppression technology. So yeah, I don't know if that answers the question.
Yeah, no, and I mean specifically in terms of the work that Johnson Controls has done around the focusing on the acoustics, you give us some idea of the research you've done, and I'm just curious. I mean, excuse my ignorance, but is it only relevant to inert gas systems, or does it apply across the whole sort of technology portfolio? Please.
Maybe I could take that one, Miguel. So this whole subject of acoustics and potential threats to the equipment within data centers really emerged about 6 or 7 years ago. And I think it's important to recognise that the noise originating from gaseous fire suppression systems hasn't changed. In general, the gaseous fire systems will generate a certain amount of noise when they discharge. What has increased, though, is a susceptibility to noise of the equipment itself. So computer hard drives have increased their capacity substantially, and with that, their vulnerability to effects of noise vibration has increased. Certainly, the initial reports of problems, so damage to hard drives and data loss, did seem to point towards the inert gas systems, which are generally higher pressure systems discharging much higher volumes of gas. But as we researched and understood the subject, we found that this phenomenon could actually occur with any high pressure system. So certainly, whilst we focused our initial attention on inert gas systems, we did find, as we introduced higher pressure halocarbon systems, that there was potential there for that to be impacted as well. And so as we started to understand more about the subject, we broadened our approach to consider the higher pressure halocarbon systems alongside the already high pressure inert gas systems.
Okay, and in terms, I mean, obviously the research was carried out for a reason to understand the problem. Then I presume you as a company have developed various solutions, approaches to addressing the issue. Can you give us some idea of what what technologies, what products you've developed to address the situation?
Yeah, absolutely. Yes, as you say, the initial research that we did was to understand the problem and quantify the problem. There were initial reports that the sounders that are included within a fire suppression system could also be a source of sound that would be a problem. And so we needed to fully understand the subject before we developed solutions. When we understood what the problem was, we then set out to design or develop and design discharge nozzles that were able to reduce the sound power being emitted, which would ultimately lower the impact on the hard drives themselves. And so we started work to understand and then develop solutions. What we also found was that whilst we could develop the equipment to reduce the noise level, we also needed to understand what was happening within the structure of the data center itself. So alongside developing acoustic nozzles, we also developed an acoustic calculator. And the acoustic calculator takes the performance of the acoustic nozzle, but also looks at the construction and the components within the data center itself and models the impact and the effect of the acoustic nozzle solution on the complete data center environment. And what that means is we're able to estimate or predict what the noise level will be at a particular piece of equipment within a data center when we use the acoustic nozzle solution. And so each data center is different, the materials of construction are different, the amount of racks are different, the location of the discharge nozzles relative to that equipment are different. And so the acoustic calculator allows you to model the impact of the noise emanating from the fire suppression system at individual pieces of equipment within the space. We believe that that is a unique solution.
And in terms of working out whether a solution therefore is fit for any particular data center environment, is that calculated? Is that the crucial bit that you can, as you say, model, understand, and then get the right solution in place? Or is it a bit more trial and error until you find the right? I guess the question is, how do you know that a solution that you're providing for a data center is going to do what is required?
Well, we're certainly confident in the capability of the acoustic nozzles that have been developed. And so what we do is we take the known performance of those acoustic nozzles and we feed that data into the acoustic calculator along with the information about the construction of the data center. And generally, the solution that we offer is fit for purpose. But what the tool does give us the opportunity to do is that if we get in results where we see that the acoustic level is too high, it does give us an opportunity there to maybe vary the discharge time of the system, to reposition the nozzles, or in some cases advise the data center operator that the racks perhaps need some additional form of shielding so that they're not seeing the full impacts of the noise. But in general terms, let's say the sustainability of the solution is around about the development of the acoustic nozzle and applying that in a data center environment, to get that optimum performance.
And in terms of sort of, if there are folks that are interested in following up, just understanding a bit more about the topic in general, where can they go to sort of get more information, to understand the situation and what their options might be?
Well, on the whole subject of the acoustics, we developed a white paper, and so that white paper has had a lot of attention within the industry. So, the first suggestion would be that people download the white paper from the website. They take a look at that. If there are other questions that arise, we'd be more than happy to deal with those. But the white paper is supported by a number of product data sheets as well on the performance of the acoustic nozzle.
Okay, and just before we finish, in terms of the portfolio more broadly, what other things have you either sort of introduced in the recent past, bearing in mind all the regrettable chaos we exist in at the moment, or are you able to share any plans as to product solutions that might be coming out during the next year or so?
Yeah, maybe I can comment on that. In the world in general and associated to renewable energies, but also to data centers, we see more and more energy storage facilities being built, and those energy storage facilities they are based on lithium-ion batteries. Now, these batteries they show an extremely high efficiency in charging, storing, and discharging energy when it's required. Those batteries also pose a risk of fire that should not be underestimated. They store a huge amount of energy, and when they go into failure, there's a huge amount of energy that becomes, I would say, expelled in terms of combustion and fire, and it's literally very, very difficult to put out once they go into failure or abuse mode, and they go into the so-called thermal runaway. So that is an increased risk in all those types of energy facilities that now include lithium-ion batteries. We at Johnson Controls, we have recently launched a solution, and that solution is based on giving a very early warning when there is a failure at the minimum component of a battery, which is the energy cells that compose the battery. And this technology is capable of sensing the off gas generated by a single cell that goes into failure. And based on that off gas, and before it goes into further cells within that battery or to further batteries, we're able to generate that early warning that allows for making different type of decisions. So we are able to go to the battery management system and generate a shutdown in that battery rack or in the container, or we are able also to trigger the release of a suppression agent that will create an unfriendly atmosphere for the development of a combustion process. So that is one solution we've just introduced. We are also introducing now at the beginning of the year a technology that will make the fire suppression systems be connected and connected to the internet and connected to the cloud and be visible from everywhere around the globe. So literally what we're doing is bringing connectivity to each of the gas suppression cylinders that are included in a system, and that connectivity will provide information on the status, on pressure and temperature on the individual cylinder, and in that way a facility manager can supervise a single system or a variety of systems installed in a certain facility, no matter where that facility is. So from a dashboard in a computer or from a handheld device, an operator would be able to look at the status and the readiness for the suppression system to operate in case of a fire being developed. And in these days where all critical infrastructure needs to perform in a very high level of availability and uptime, those type of technologies that we're now bringing into fire suppressions are going to be key for customers and facility managers.
Okay, so I mean, we covered quite a lot of ground today, which was great. And then just in terms of any sort of final thoughts for people in terms of the fire suppression issues, whether at a high level or specifically around the sort of acoustics, yeah, whether it's Alan or Miguel, if you want to share any sort of final thoughts.
Yeah, my thought would be there's constantly new processes being introduced into different type of industries, and within those new processes where we gain efficiency in one or the other way, we encounter always new type of fire risks, and that's our passion. I mean, we are constantly trying to identify what is a new risk and how can we protect it, and we have testing and research facilities in several places on the globe that are dedicated to looking into those new areas where we can bring products that protect assets, people, and processes.
Yeah, and I think just to add to that, I think with with the products that we've discussed during this call, it should demonstrate that Johnson Controls is an innovation leader. Those solutions that we've discussed there, with respect to acoustics, with respect to lithium-ion battery protection and connected systems, didn't really exist a few years ago. And as the market and the applications have evolved, we've invested in that level of innovation to bring us to the point where we can introduce these solutions.
Okay, well, that's brilliant. I really appreciate your time today. So Miguel and Alan, thanks very much indeed.
No problem. Thank you.
Thank you very much.